Humanity has always been obsessed with predicting the future. When we looked at the stars, we found perfection. We wrote Newton's law of gravity. We wrote Ohm's law of electricity. In classical physics, the universe is deterministic. It is a flawless machine. If you know the inputs, you can predict the exact output. But then, we tried to predict human behavior, and the machine broke. Economics is not deterministic. It is what we call stochastic. The word stochastic sounds like a terrifying mathematical term, but its origin is surprisingly simple. It comes from the ancient Greek word stokos, which simply means a bullseye on a dartboard. Imagine throwing darts at a target. You are aiming for the absolute center, but your throws scatter around it. There are misses, variations, and unpredictable gusts of wind. That is human behavior. We aim for a pattern, but the outcome is filled with random noise. That is the essence of econometrics, finding the hidden truth inside a storm of random data. So how do we measure something that is constantly scattering? To find out, we must travel back to 1886 to a brilliant Victorian scientist named Francis Galton. Galton was studying the heights of human beings. He collected data on hundreds of families and noticed a strange, invisible force at work. He realized that exceptionally tall fathers tended to have sons who were slightly shorter, and exceptionally short fathers had sons who were slightly taller. The extreme heights were being pulled back toward the average of the human population. Galton called this unseen balancing force regression to mediocrity. He drew a line through his scattered data points to represent this pull. Today we simply call it the regression line. It is the glowing thread of destiny that finds the average signal within the noise of human genetics. Today the word regression has evolved far beyond human height. Modern econometrics uses regression to study dependence, how one variable depends on others. Let us make this real. Imagine you are a farmer. You want to predict your crop yield. You know that rainfall and temperature cause crops to grow. So you build a model. But even if you know the exact rainfall down to the final drop, you can never predict the yield perfectly. Why? Because reality is messy. There are hidden bugs, soil variations, and 1,000 tiny secrets you cannot measure. Econometricians represent all these unknown secrets with a single letter. U, the stochastic disturbance, or the error term. The error term is not a mistake in your math. It is a proxy for all the neglected variables that affect reality. It is the shadow of human free will and the infinite complexity of nature itself. But here is the most dangerous trap in the universe of data. Regression is blind. It measures statistical dependence, but it can never truly prove causation. Listen closely. A statistical relationship, no matter how powerful, cannot establish cause and effect. If I show you a graph where ice cream sales perfectly match a rise in shark attacks, the mathematics will give you a flawless, beautiful regression line. But eating ice cream does not cause sharks to attack people. A third hidden variable, the heat of summer, causes people to buy ice cream and swim in the ocean. The data cannot speak for itself. It requires a human mind. It requires economic theory to give it a soul. To build these models, we need raw material. The fuel of econometrics is data, and it comes in three fundamental shapes. First, time series data. This is tracking a single entity, like the GDP of India, over a long period of time. Second, cross-sectional data. This is a frozen snapshot in time, like measuring the wealth of 50 different countries at this exact heartbeat. And finally, the Holy Grail. Panel data, a beautiful three-dimensional matrix that tracks multiple entities across the passage of time. By mastering these numbers, we take the infinite, chaotic actions of humanity and draw the line of best fit through the noise. We do not just calculate, we understand.